Hey guys, Alan from Hack Gadgets here. Okay, so I got 3 of these FLATRON monitors. It's LG. It's the FLATRON W2052TQ. I've been using these, well, I had been using these for about 3.5 years, and all 3 of them, month after month, they failed. So I got 2 more behind me here. The first one failed and I figured, okay, well, electronics does fail after a while, and it was just it's time to go. After the other 2 failed, okay, obviously we have some sort of defect with these things. They were out of warranty, so, too bad, so sad as far as warranty replacement goes. So let's crack these open on the bench and see what made them fail. Okay, so here's the 3 monitors. These 2 are right now exactly the same. When you apply power and turn them on, you get nothing, just a black screen. This one here is, I believe, the last one that I was able to use, the last one to go. And it actually does display a little bit of information. The LG splash screen does come on for a little bit, and then it quickly disappears. So, as far as the symptoms go, what was happening on these is, as long as they were powered on, you could use them for quite a while. And what was happening was, if you ever did power it down, like physically disconnect power to it, not sleep mode, but physically powering it down, you could press the power button, things would come on, and then generally it would go away. If you did that 5 or 6 or 10 times, it would eventually come on and stay on, and then it was good for a while. This one here, let me power it up. This is the only one that's plugged in right now. What you'll see here is, if I power it on, you should see there's the LG splash screen, and okay, we saw it for a second. It said check signal, check the cable signal, something like that. So that message that came on here, it's still being displayed. We can't see it though, but that wouldn't go away. That should still be here. So the panel actually did just go out. So it lasted, whatever, 10 seconds or so. And this blue light down here is still on. So let me try this again. Okay, I saw the panel flicker when I turned it off. The blue light is off here. Let me turn it on again. We get LG. And I think that should still be there. It flickered. There, we get check something. It flickered again and it's gone. And this blue light is still on. Okay, so first part of the disassembly, actually quite easy. I'm sure I probably put these on when I got them. 4 screws takes off the base here, off to the back. Now, so this is the absolutely crappy part of it. There are no screws anywhere on here to take this thing apart. This is one of those completely snapped together constructions. What a piece of junk. So I can see that there's basically a back piece and there's a front piece here. So I'm going to try to do some prying on the inside here just to snap these apart. Okay, not sure yet if this bottom piece has to come out, but it looks like the silver portion is a separate piece. And I'm using one of these little plastic spudgers here. I got a couple different ones. Also have a metal spudger, as well as a couple more sort of more gentle ones here. Okay, so bottom piece is off. There you can see all the different snap pieces they have. Bear in mind, I haven't taken one apart yet, but so far I'm thinking the easiest way to do this is to take off this faux sort of bezel here, and then right in the corner, underneath that bezel, you can see there's kind of a little hole here. And if you get a screwdriver in there, this is just a small flat blade screwdriver, something with a bit more leverage than a spudger, and something that's narrower than a spudger, if you lift up and pull in, that will pop the first one there. And then from there I'm thinking I'm going to use one of these to continue my way down. Okay, so I think I have the technique down. I got this side out, so I'm just going to work along the top here. And as far as I can tell, this technique doesn't damage things too much. Maybe it might mar it up a little bit, but basically put some leverage on it and then work with this tool and sort of just flex it as you pull it along. Allows the catches to release. This one just released here. And I'll move along and get the next one. And it does seem to get a little bit easier as they get released one by one. Now, this monitor isn't a brand new monitor, so you know, if there's a couple little scuffs and scrapes on it, I'll probably use this on a CNC machine or something, so I'm not so concerned. If this was a brand new monitor and was 5 months old and I was doing this, well, I might not be so so happy about it. But well, so far, little tiny scratch here, but yeah, it doesn't seem to work so bad. Okay, so far so good. Worked on the top here. I'm just finished off the side, and so far so good on most of them. Here, let me see here. Yeah, you can tell. Whoa. This whole monitor on the inside just fell out. I guess nothing is holding that thing in. That's crazy. It's just sitting in there. This bezel, the snap-on bezel, was the only thing holding the monitor in. That's, well, that's kind of ridiculous actually. There should be some screws holding that thing in. Anyway, what I was going to say is a couple of these little things here, like this one here, you know, if that'll focus on there. These catches aren't super strong, so like that one did fail. But most of them, you know, like that one is okay. Most of them survived. So all I have to do is this front half here, and this bezel should be off, and it's almost falling off as it is. Okay, so finally got the bezel off, and I actually underestimated that. This bottom piece here, the sides both came off real easy, but the center portion here, man, was that ever tough. They have these, let's see if it'll focus on this. They have these clips here, and they are really in there good. Just the way those clips are sort of, I don't know, just sort of well clipped in. This camera doesn't like to focus on this screen. I guess it's a little bit too matte for it. Now this, if you can see, is horrible. I just lifted it up. This whole screen on the inside, it's flopping around like anything. This is such a joke. Like, it's just sitting here. I didn't take it out. I didn't disconnect anything. I just snapped off the front bezel. Like, if you hit this thing hard on the ground, that front bezel would probably snap off, and this thing would be like, it would be out. It's just sitting there. I can't believe that. It's just sitting in there. Nothing's holding it in. I've kind of lost all faith in LG's build quality now that I see this. You know, LG stands for life is good. Well, man, with this kind of build quality, life is not good. That's just a pile of crap. Okay, and what do we have in here? So here's the small board here when you push these buttons. On the bottom left corner, that's just hitting some, looks like some dome switches in there. So this has a little cable that has to come out. So two cables actually that have to come out to disconnect that. And here's the metal bracket here that goes and connects the stand. And then over here we have, this is just the power button, and there should be an LED on there also. Yeah, there's the LED that lights it up. And this one has a connector also on it. And I think those three connectors on those two boards is all we need to do to disconnect this thing. Okay, I was wrong on that. This one here, this wire actually just comes over and gets connected to this guy. So the only connection that has to be taken off is only this one here. So that's been taken off, and this panel should be loose. Okay, so this thing flopped right out, and yeah, nothing was holding it in place, and nothing was designed to hold it in place. It's just sitting in there. And more crap construction. Like, take a look at this. We have these tabs here. So these tabs are designed to slot into something. It looks like it anyway. That's what I'm thinking. All over the place. But this thing is just sitting here. Like, there's nothing holding this in place. So, you know, this is just sitting in a cavity in the molded plastic. Like, I don't know. This just looks like junk. Like, this is the connectors here. So when you're pushing a connector, you're just relying on the molded plastic to hold against your push. Like, this thing isn't even connected to the panel. Okay, so I got this portion of it. This was just flipped on here. The only connection it had was there was a ribbon cable right here, which was connected over there. So that just I just pulled out. And here's the interface board. So this is the one where your VGA and DVI plug into. A lot of small caps on here. Probably not our problem because we're having more of a power supply problem, which I'm assuming is this big guy down here under this sheet of plastic. Okay, so this thing was held in with a little clip right here, and these wires here were just snaked into this little cavity, and I'm not sure how this little piece of metal was held on. It just fell off right now. I guess, well, maybe it's maybe it's held on with tape, I don't know, but this shielding metal, it just fell off. So I'm not sure if it was held in on this little tab on this side or something. I don't know. Not too impressive anyway. Okay, so here's the back of the power supply board. You can see a little bit of heat damage there. There's some holes through there, so I'm thinking that's they're not vias. They're not plated or anything, so I'm thinking those are vent holes. So I'm sure we have probably a large transformer on the other side of there. And here's some power supply stuff. No visible damage here. They didn't clean the board very well when they were manufacturing this. You can see a lot of the remnants of the wave soldering. Okay, so there's one connection here that was held on with a bit of tape here. This is just a squeeze and pull connector. And once that's out, we do have a couple connections over here that I don't believe are socketed in any way. So those will stay. And this whole board lifts out. There we go. Okay, so it turns out these are socketed also. These are again just ones you can just you can squeeze and pull. And here's the other side of the board. And what do you know? If I was a betting man, I would say this little chrome dome here and this little chrome dome here are done, if visual indication were anything. Okay, so on the back of this board here, these are the ones that I think are going to be needing to be changed. And there's actually 3 values of this one. I think it's these 3, if I'm not mistaken. Yes, so these are 1000 microfarad 16 volts, these two, and this guy right here. And then there's three values here of these other ones. And those are 470 microfarad 35 volt. So what I'm going to do is I do have similar devices here in stock. These are Nichicon devices, and it's a little bit bigger, so it's not an exact replacement. You can see the size difference here, but I think it will fit. The lead spacing is identical, and these are slightly different in value. It's 1000 microfarad 35 volt, so that'll work just fine, replacing 2000 microfarad 16 volt. And these two here, they're actually in parallel. In the back here you can see that's these connections right here. So they go just directly across those two points. So we'll desolder these guys and pop the new ones in. And before I do that, let's take a look at the value of all these caps here. I've already done this, but let's take a look with the ESR meter here and see what our results are. Okay, so the points that are indicated with these arrows here, this and this, are the two caps that are bad, and that's the bulging ones. So here's the ESR meter. It's on automatic, and I'll connect it to, so this is actually just going across both of them. There is no way to isolate it in circuit like this. So this is basically a 2000 microfarad capacitor. And so what we have here is, it says, so this is the automatic reading. It says 0.294 ohms, and it says this is good for a 25 volt E-cap, good if the capacitance is less than 330 microfarads. So this capacitance is not less than 330 microfarads. In fact, this is 2000 microfarads with those two caps in series. So in parallel. So no go. That's a bad cap. Now let's take a look at the next ones. So the next ones over are these guys, and those are also directly in parallel. So we'll pop it onto there, and we'll see what we get with these ones. A little hard to connect on these little leads here. Okay, so I'm holding it in place. Much lower value, so I got 0.013 ohms, and it says this is good for a cap with low ESR. So it's saying, hey, this is a good cap no matter what it is. That's nice and low. So those caps look good to me. I do have the correct value caps on order, but I figured, well, I'll just use the ones that I have on hand here, even though they're not quite the right size. I think I'll be able to jam them in place there. Okay, and let's take a look at these outliers here, these two far ones. So this one is over here. .009 ohms. Again, it says it's good for low ESR cap. And where's that other guy? Right over here. Okay. And again, super low, 0.013. So there we go. Two bad caps. And the other ones, even though this one here is the same type as these two, obviously these guys here are under some extreme stress. Okay, so this is live. I got 110 volts hooked up here, and what I've done is I've just there's actually a few spots I've just soldered temporarily. Some connectors over here. This is negative, this is positive, and I've hooked up a scope. These are still the old caps. I just wanted to see what it looks like on the scope before I change them. Might as well. And what I've done temporarily is I've removed this board from the chassis, a couple screws, and actually I had to remove the posts, these guys here, for those for the connectors, and then this whole board came out. So I've connected it over to the panel. I've connected the power supply over to this board, and I've actually just taken out, this is the configuration switch panel here, and this is the one that was on the right hand side. This is the power switch with the power on LED. I've just removed this. So this is basically all of the electronics that's normally inside the case, and it is all wired up like it normally would be when it's in full use. So let's take a look and see what this looks like with the scope. And I'm being extremely careful because we got some really high voltages on this board here. So doing one hand rule and all that sort of stuff, of course. So believe it or not, I just took a look under this panel and it's actually on, and it's displaying the whatever that default message is, you know, there's no input sort of thing. So, well, for a few minutes anyway, it's actually livened up. So this is probably very, very borderline to where it can and can't work. So, well, we know right now it is working. So with what we see here, this is actually okay. So this is AC coupled, and we're right across those capacitors. We're on 0.5 volt per division here. So this is showing us the ripple on that cap. And it's crazy. So this is almost 2 volts of ripple on there, which is nuts. And we're DC coupled here. This is 0 volts here down at the bottom, and so here we can see our waveform. And I just got some stats on here. So our max voltage is 5.92 volts. Our minimum voltage is 4.28 or so. So that's giving us a swing of about 1.7 volts or so, 1.6, 1.7. And we can see here, here's our average voltage is 5.18 volts. So this looks like it's a 5 volts output for some circuitry here. But man, it's dipping down, you know, very close to the 4 volts mark, which is, I'm thinking, not what they had expected the circuitry to run on. Okay, got the desoldering tool here, and I let this board sit, and I've measured some voltages, and I've shorted out some caps just to bleed off anything small on here. So it's time to take these out now. Got some pretty good planes on there. Takes quite a bit of heat actually. But man, the Heiko tool just does the job. It's wonderful. Okay, 2 are out. Okay, so new caps are installed. They actually do fit. It's a bit of a snug fit, but there's nothing in the way. I was thinking I might have to actually mount one over here on the board and maybe hot glue it and just run some leads over, but yeah, it actually worked okay. And the moment of truth. This looks way better. So again, we're in DC coupling here. 0 volts is right at the bottom here, so this is our 1 volt per division, so we're 1, 2, 3, 4, 5 volts, and we got the stats on here so we can take a look at some measurements here. So our max right now is 5.7, and that's a little bit maybe misleading because this is these little tiny spikes here in the waveform. Our minimum is 4.8, and again that's just these little tiny ones. Before we were having those huge dips, so that's just these little tiny items here. And our average is 5.26. Okay, so check out this. This is the board that's I'd taken out so that I could temporarily test the entire electronics without it being connected to this big back cage here. So this is the metal cage that all of the electronics were mounted in. And so I took off the 4 screws that were holding this in, and 2 screws that actually hold it in place. So these actually go through and fits through the chassis so that the connections can be made on the bottom. And there's 2 screws, one over here and one over here. So you can see that there's a piece of formed metal here that's threaded for that one screw to go into. There's a piece of bent metal over here for the other screw. There's actually a little knockout over here, a little bump out, and so that's for the bottom of this connector. There are some protruding connections on there, so that's good. And there is no connections over on this part here, and good thing, because this is actually just resting on this edge here. So this is physically just sitting on this edge. And I guess that's okay, except for, check this out, there is a screw hole right here, but there's actually nothing holding this down. So you can see how close it is. Now that might be a little bit better once this gets bolted in and once these screws get held in place. So that's kind of how it is, but you can see that board is actually angled. And that's angled by design. So since that board is angled, obviously these connectors are slightly angled. Not that it matters. It's not angled, such that you can't get a VGA cable on there. But why not design this so that that board lays flat? Why not design it so that there's a standoff under that corner? I don't know. I think LG rushed this to market and cut a few corners. We are back in business. You just have it hooked up to a laptop computer here, and we are working good. It's been running for about 20 minutes now. Not a flicker, not a problem. And just a side note about these panels, which is actually kind of cool. This is the connection over from the control board to all of the buttons. So these are just the different option buttons on the front, and this just jumpers over to the power button and power on indication LED. I'd forgotten to plug that in, and it powered on. And I was pressing the power button and trying to switch it off, and nothing was working, and the LED was staying off, and I was wondering what was going on until I figured out that, I forgot to plug it in. So just a nice little side effect that if you just want this thing to turn on, never to be able to turn it off, just disconnect that jumper and you can install this panel into anything without all those pesky on buttons and stuff. So anyway, this panel was successfully brought back to life. I feel sort of gypped on what I paid for it way back when I see the quality of construction. But anyway, I guess it's better to have a working monitor than tossing these things in the garbage anyway. So there's 2 more monitors to go. I think that'll take me probably about another half an hour. And if you want to see some more high-res pictures of this, go over to hackedgadgets.com. And remember, always have fun. For more information, go to hackedgadgets.com.